Section 2-2, the distributive law. So this book calls the distributive property, which you've probably heard it as, they call it the distributive law. And what it does, we are pretty familiar with this, it gives us two ways of calculating the same number. So, for example, if Thomas's bill at a restaurant is B dollars and Sam's bill is A dollars, and they each want to pay a 20% tip, there are two ways you could calculate, and notice we're finding the total tip here. The total bill is B plus A, Thomas's bill plus Sam's bill, and the total tip would be 20% of that quantity. So one way you could do this is 0.2 times B plus A. Alternatively, Thomas's tip, you could figure his out specifically, is 20% of B, Sam's is 20% of A, so you could add those two together. And since they represent the same quantity, it's logical that that and that quantity are equal to each other. So if we look over here, the distributive law for any numbers A, B, and C is that when you have A in front of the parentheses with B and C, it can be distributed to both of those to give you AB plus AC. And the way that you could say this is that the multiplication by the number A is being distributed or distributes over the sum of B plus C. Okay, so let's slide down here to example 1. There are a lot of examples here, but this is stuff you've seen before, so a lot of these will look pretty familiar, but a couple new things as well. It says, use the distributive law to write two expressions for the perimeter of a rectangle and interpret each expression in words. So I do want you to pause this for a second and see if you can come up with the two different expressions. Okay, so now that you're back, let's see if you came up with the same expressions that we need here. So for perimeter of a rectangle, if we just draw that, we know that this is the length and this is the width. So the two different ways that we could write that to calculate the perimeter, which is all four sides, we know that we could do 2 times the length plus the width. So you could add these two sides and double that sum, or because you have 2 lengths and 2 widths, you could also do 2 times the length plus 2 times the width. And we also interpreted each of those expressions in words. And again, based on the distributive law, we know that these two quantities are going to be equal. Now we can slide over to example 2, and my writing traveled with me, so I'll erase that as I read the directions. It says, use the distributive law to rewrite each expression. So again, I want you to go ahead and pause this for a second, try to do all 3 of these, and then go ahead and check your work. So after you've done yours, when we distribute here, we get 6S plus 18W, and that's our answer for A. Our answer for B, we're going to distribute that to all 3 of those, so we get 4S minus 12T plus 16W. And then for C, same thing, we're going to distribute it to each of these. They're all variables, so we're going to get AB plus AC minus AD. For example 3, we can see that we have some subtractions and some negatives in front of the parentheses. And the one thing that they remind you in the textbook is to remember that when you have a quantity like that, the opposite of x or negative x, that really means -1 times x. Okay, so that'll help us. They want us to express this in a simpler way. So we know that we can take that negative and distribute it to both. And we know that minus d, those are stuck together, so that's going to give us negative c, and because we're distributing the negative to the subtraction of d, that's going to become plus d. So negative c plus d, and then we're subtracting this whole quantity, so it's sort of like you're just distributing -1 to both of those. So that makes it negative d or minus d, and then minus c. And they do want us to finish it from there, so adding d and subtracting d will cancel out, which would give you a final answer. When you add negative c plus negative c, you get negative 2c. All right, slide over to example 4. Like I said, a lot of examples, but we'll be able to go pretty quickly through these. All right, example 4. Let n and k be positive integers. Show that n minus the quantity n minus k and that entire quantity cubed does not depend on the value of n, but only on the value of k. So if we take a look at this, same thing as the last example, we're allowed to go ahead and distribute as if that's negative 1. And because it's all, and I'm going to put brackets here, because it's all within this set of green brackets that's being cubed, we can do that. So now that gives me n minus n plus k, and then that quantity cubed. And inside the brackets here, n minus n, again, is going to cancel out. So all that you're left with is k inside those brackets being cubed. Example 5 says show that negative x plus y, all of that over negative 3, is equivalent to x over 3 minus y over 3. So what the textbook mentions here is that you can distribute division over a sum as well, because dividing by negative 3 we know is the same as multiplying by the reciprocal, which is negative 1/3. So each of these terms is going to be divided by negative 3. The other way to think of it is that it's negative 1/3 being multiplied by negative x plus y. All right, so if you think of it like that, it's pretty easy to see that we just divide each of them by negative 3 or multiply by negative 1/3. So that'll give me 1/3 x minus 1/3 y, which we know we can rewrite 1/3 x as x over 3 minus 1/3 y, which can be rewritten as y over 3. And that's how we get the same quantity right there. Example 6 talks about just being careful that you can't distribute everything in a problem. So if you take a look at A, B, and C, the question is, are the two expressions equivalent? So if we look at example 6a, you can distribute over addition like that. So 10 times the quantity x plus y and 10x plus 10y, those two are equivalent. All right. Here, though, when you have a 2 outside of parentheses with xy, you're not allowed to distribute 2 over a multiplication problem. So you're not allowed to do that, so these two are not equivalent. The last example here, example 6c, we want to see if we can distribute a square root over a sum. So is the square root of s plus t and the square root of s plus the square root of t, are they the same quantities? And what we can do is plug some values in. So if s is 9 and t is 16, and we plug those values in for this one, we would get the square root of 9 plus 16, square root of 25, which is 5. And we want to know if that's equal to the square root of 9 plus the square root of 16, which would be 3 plus 4, which is 7. So they're not equal, so you can't distribute that. You can distribute multiplication, like we have up here, over addition or over subtraction. And that's what we learned from this page. For example 7, we get into a practical application of the distributive law. So it says in the expression for a student's grade that we used all the way back in chapter 1, this term right here represents the contribution from the 3 test scores T1, T2, and T3. And we want to show that this expression is equivalent to 0.2 T sub 1 plus 0.2 T sub 2 plus 0.2 T sub 3, and explain what this means in terms of grades. So what we can do is we can take that parentheses from all the way up here, or that problem from all the way up here, and you're going to do 0.6, and because all 3 test scores are the sum of all 3 test scores is being divided by 3, that's the average, we can pull that divided by 3 out as 1/3, and then multiply that by T sub 1 plus T sub 2 plus T sub 3. So when you multiply 0.6 times 1/3, you get 0.2, and then that times T sub 1 plus t sub 2 plus t sub 3. So using the distributive property, we can distribute 0.2 to each of those, and that'll give us 0.2 t sub 1 plus 0.2 t sub 2 plus 0.2 t sub 3. And the question was, explain what that means in terms of grades. It means that if your overall test average is worth 60% of your grade and you have a total of 3 tests, that means that each test individually is going to be worth 20%. Example 8 says, which of the expressions from example 7 would you use in these two situations? First of all, if you knew all of the test scores and wanted to compute their contribution to your final grade, what we would do there is we would just go ahead and use that original problem, which is 0.60 times t sub 1 plus t sub 2 plus t sub 3 all over 3. If you have all the test scores, it would be very easy to plug those into this formula, find the average of the test scores, and multiply by 0.6. Now, if you wanted to know the effect on your final grade of getting 10 more points on the second test, now it makes more sense to use the distributed version of this formula up here, 0.2 t sub 1 plus 0.2, and now we're going to multiply that. What if you had gotten 10 more points on your second test? So you're going to take in parentheses t sub 2 plus 10, which increases that, and then plus 0.2 times t sub 3. And this is an easier way to do this problem because all you have to do is increase that part right there. And overall, the effect that that would have on your grade, because you're going to distribute 0.2 to both the original test score you got on test 2 and 10, it would improve that part of your grade by a total of 2 points, because 0.2 times 10 is 2. Example 9 is going to lead us into the next section, which deals with factoring. So it says sometimes we use the distributive law from left to right, where you take A and distribute it to B plus C to get AB plus AC. But other times we want to use the distributive law from right to left. And this is the way they're saying left to right, right to left, the way that it was originally given to you. So if you have AB plus AC, you can reverse the distributive law and take that A out, which is called, we know, factoring out. So you're factoring out the common factor, A, because this quantity has A, this quantity has A, and we basically put what it would look like before the A got distributed. So example 9 says take out the common factor in the following problems. So take a minute to do these ones on your own and then check back. Okay, so for A, we have a common factor of X, and when you factor that out, you get X times 2 plus Y. For B, you have W, but you could also factor out the negative, which oftentimes will be pretty helpful. So let's take out negative W, right? So the negative W being taken out of there leaves me with X. And then the negative, because we're subtracting that, negative W taken out of that would leave me with plus 2. So your final answer is negative W times X plus 2 once it's factored out. This one here has a common factor of m squared, so we factor out m squared and we're left with 121 minus, and this is always a tricky one for people, even though the m squared is all that's there, you still have to have a 1 over here because that got factored out. For example 10, I want you to try to do these on your own, and then I'll have the answers up here so you can check them. So pause your video and then go ahead and work on these on your own. Okay, so hopefully you've worked through these, and I'll leave this screen up here for a second so that you can check all 6 of these to make sure you got them. E and F were a little more challenging, but like I said, these will lead us into the next section. And you can see this one here had 3 things that were originally being added and subtracted together. So when you factored a plus 2 out, you were left with 3 terms inside the second parenthesis.